So our next speaker will be Łukasz. He will tell us about black and why we should stop worrying and embrace auto-formatting. There won't be any Q&A afterwards, but please give him a warm welcome.
Hi, life is better painted black. We're going to talk about auto-formatting black, or as Raymond put it, lack of color. My name is Łukasz. I come from the internet. You can find me on GitHub, Facebook, Twitter, or email if you want. So yeah, like I'm happy to hear about synthesizers, Fallout, and other RPGs, and obviously all the formatting and the future of Python. But today we're going to go around the problem of auto formatting. So first, we're going to define like why auto format code at all. Like what does that give you? What do we do about doing it right, and what do we know about doing it wrong? We're going to go and talk about syntax trees. How does a computer interpret programming languages? Why does modifying source code help us, and how is it done safely? We're going to talk about how I actually implemented black, like the auto formatter, and how you could implement a tool like it if you decided to do it yourself. Obviously, it's not the only way, but I'm just going to show how I did it. And then finally, we're going to go and talk about some fun problems that I didn't anticipate on day one. So let's start with the problem statement. And the problem statement, in the words of my dear friend Jack Dietrich, is that code is the enemy. He says, I hate code and I wish we can have as little of it as possible. And I agree, right? Code is complexity. It's very hard to see how all those pieces connect together. In fact, at my time at Facebook, when you were dealing with millions of lines of code, you clearly see that there is no way a single person can actually understand the entire thing. So you want to remove as much confusion from reading code as possible. And this is where code style comes in. So what is it? Well, code style is pretty much an agreement between a group of people on a team, how certain parts of the code which are not important for the computer should be expressed so that they're easier for humans. One of Guido's key insights was that code is much more read than written, much more often read than written. So that includes code review, right? So the code style that you have should accelerate code review and not slow it down. So it should decrease the round trips between the author of the change and between the code reviewer. It should remove noise so that we can actually focus on the logic behind the code and not on things that are inconsequential. And diffs should be as small as possible, which helps in both. But I'm talking about teams, but you are also not the same person in time, right? So at the team of one, is important as well, because if you're maintaining a piece of code over time, like in 6 months or 18 months, you might be kind of surprised by some decisions that you made in time. And having differences in formatting at the same time just creates, more tension and more friction for you to understand, like, what the hell was I thinking at the time? So maintaining a consistent code style just makes the code transparent that way, which means you can focus on the actual logic, on the things that are hard. So we have PEP 8, right? So obviously everything is solved and we can just move on with our lives. Well, PEP 8 was a style guide for the Python styling library. It was written in 2001, revised a few times, most recently in 2013 and 2016. But it's a style guide for Python. It's like a framework for creating code styles. It, in fact, itself suggests multiple ways of folding code that is too long and how you can do certain things. And it itself, like, it focuses mostly on the fact that a foolish consistency is the hobgoblin of little minds. So in particular, a style guide is about consistency with this, document, but more important with a project, and even more important, you have to be consistent within a file or a function. So what do we do about that? Well, we argue, right? Because we have PEP 8 now, but even within PEP 8, there's so many ways to do things. So to go from a style guide to a code style, we need to kind of settle on a subset. Like, what are we going to do? We can settle on a subset by documenting what that subset is. In practice, most people don't really do that. What they sometimes do, they put some wiki page, and wiki is this Polynesian word for where information goes to die. So they just put it there, nobody follows it. But the most often taken approach is just to have a word of mouth, like, oh, we don't do things around here like this. So how do you enforce it so that it helps other developers have your same style? Well, you can either engage humans, which are expensive and fallible, during code review to maintain a code style, or you can use linters in editors and CI, right, which is, I think, still the most popular approach. But linters are not really solving the problem, right? Like, human code review sucks for code style enforcement. It literally sucks time and effort out of humans. So people get tired just arguing about inconsequential stuff, and they miss the forest for the trees. But linters suck even more, right? They slow you down. They're too dumb to actually understand that, oh, there's an edge case here and I really want a thing. They're too dumb to always tell you consistently that a thing is wrong. But mostly they're just disappointing because they will tell you that a thing is wrong, but very rarely, especially in the Python world, they will fix a thing for you. So auto formatting is way better, right? Because it removes code style enforcement from the equation, right? You don't have to be conscious about code style anymore. There is no linter that slows you down during editing. There is no linter that slows you down during pull request submission. And reviewers don't have to comment about style transgressions and slow you down. So you don't have to slow down yourself by formatting code when you are typing it. You can just write code that is ugly, and then on save, it's just going to turn nice again. So if automatic formatting is so great, then why doesn't everybody use it? Well, the simplest answer is that if automatic formatting feels too destructive, then it is not used. Like, you are tied to, you liked how you formatted things yourself, and you wish for a tool not to break that, tidily organized code. But one of the nicest insights that come from the Go community is that uniformity trumps perfection. The good enough uniform formatting style is better than having lots of different formats that are locally better, but they're now inconsistent. So the value of style guide is just to provide that uniformity for you. And the more people think about their own formatting style, the more they get attached to it, and we're back to square one, where people have to enforce the style manually because there is no way to automate it. So Go has Go format, which pretty much resolves the issue there. JavaScript has prettier. And I used to actually work on the same floor with the author of prettier. He had a lot of input early on in Black's design, and kind of questions about community adoption and whatnot. So I'm eternally grateful for the guy. He's great. Hi, Christopher. Hi, Christopher, if you're watching it. Yeah, and then there's Black that I wrote for Python. So how does that work, and why can you even use it? Well, let's talk about trees for a second. Why can we even write safe code transformation tools? Well, because we have grammars, and those grammars tell us exactly what a given piece of code can do and what does it mean. It's context-free, meaning every time a piece of code is read by the computer, it's going to understand it the same way. So the notation we're going to use for this very short example here is the actual notation used by Python 3.7 sources to generate the parser. A programming language grammar consists of two kinds of symbols, right? There are tokens, those are all caps here, and non-terminal symbols. So these are all the others. So the tokens are atoms. These are the ones that are actually read from your file and fed to the parser. The tokenizer just sees oh, this is a string. Here is a string. Here's a number. Here's a number. And the non-terminal symbols are produced with the rules like the one on the slide, right? And the production really looks like this. The thing on the left, colon, is produced from the things on the right. The first production that we have in a grammar file is called the start symbol. And as you can clearly read here, oh, file input. So that's the entire file. And what do files consist of? Well, statements and new lines. So that's kind of easy to read. And if that production that we have always has just one name on one side, and productions that are either non-terminal symbols or tokens on the right side, we call those things context-free grammar, CFGs. That makes it deterministic. So just quickly following, can we actually go from here to just the terminal symbols, the tokens, just to see this one branch to the leaves in that tree of the Python grammar? Like, let's try to go through it and see what happens. So, as I said, a file is consisting of statements and new lines. So what is a statement? Well, it can be either simple or compound. So if it's simple, what does that mean? Well, there's going to be a bunch of small statements delimited with semicolons, right? Cool, so what are small statements? They're expressions, deletes, passes, flow statements, imports, whatever, right? So what are expression statements? Well, they are lists of star expressions and tests. And what are those? Like, well, you have annotated assignments, augmented assignments, and you clearly kind of see like, oh, this composes together. And the most fun thing about this is that soon enough, you're going to get to a moment where you see, oh, there's operators. There's or and not. And if you read from top to bottom, you know that, oh, this is actually operator precedence. And it's implemented right there in the grammar. So it's not even like, something that Python has to think about, because there's just one way to read the file. And if you go even deeper to the expressions, you're going to see that there's even more operators. And again, this is their precedence, which is pretty cool. And finally, we get to tokens, right? So that's the grammar that we're going to operate in. Like, there's a reason why I'm showing you this, and it's going to be obvious in a second. So yeah, like, note that in our short journey, we didn't even touch compound statements, right? Which include if else statements, and for and while loops, and try except statements, and so on. So we didn't get to function calls and function definitions and classes and so on. So grammars for real programming languages tend to be really big. So how does Python actually parse those files? If we were to create a parser for a grammar like this, manually, writing all those if-else statements ourselves, that would be super error-prone. Like, nobody has been doing this like since the 70s. Instead, we are generating a parser from the grammar, which is a bunch of generated code. But generator is written in Python. What it generates is a bunch of C in case of CPython. All right. So to show you how Python, the interpreter, actually sees the source code that we are dealing with, let's just see like some example code, right? So this code has just this main function which opens a file and then uses a visitor to just print lines in that file. Like, simple enough. So an AST that we're going to use, and you see the AST on the right, like, is the actual object-oriented version of the lines that we have. So there's a module which has an import. That import has an alias. Obviously, we are not using the alias. There is no as name, so that's none. But it does have a name, AST. So import AST is that import. There's the import from that it follows, right? And from the first level, we have this module simple visitor, and we import names from it. We can import many, but in this case, we just import one, and so on and so on. When we get to a function definition, we see that, oh yeah, it has arguments and whatnot, and then we get to the body of the function, which starts with a with statement, and so on, and so on, and so on, right? So finally, just like this for loop, you can see like, oh, there's a for loop, and it has an expression that, is now, we iterate over and whatnot. At the very end, the thing that I wanted to tell you and I wanted to show is that this is an abstract syntax tree. What that means is like it's this beautiful operational thing that specializes nodes for every possible construct in a language. They throw away insignificant details like white space, optional parentheses, comments, so we can just focus on the things that Python is actually going to be running, right? But hang on. The formatter actually has to know about those insignificant details, right? Like, this is the ones that we care about. White space, optional parentheses, and comments. So what should we do about that? Well, we don't use an abstract syntax tree. We use a concrete syntax tree. And in Python, we ship one. Part of lib223, there is a concrete syntax tree implementation that we can use, and Black is using it. The output of it looks quite different. if you look at the same file, you're going to see that there's file input, and there's a simple statement, import name. That name is literally import, and then there's another name that follows that has a bunch of white space and says AST. So it's simply just a bunch of containers and tokens that just have content, and maybe some white space that come before the token. So there's very little specialization here, and the thing that I really wanted to express is how even things like def in the function definition is just a name that is prepended by a bunch of empty lines, and it literally just says def, and then there's a space, and there's main. So we no longer know for sure what does the code mean. We are not operating on a logical piece of source code anymore as an abstract syntax tree. We're operating on the tokens as they go and just organize them in containers so that we don't lose the information about comments and white space. So this is the kind of low-level thing that I had to operate with writing Black. It is way more verbose, so it takes way more time to just scroll through this, so we're not going to do this. Well, what I wanted to show you really is that we do have a concrete syntax tree that we can use. And a fun thing that you can see in this particular slide is that there is an indent and dedent token that we are using. So if you really, really squint, you know that Python doesn't have braces, but it does. Right? The indent and dedent tokens are really just, braces in hiding that we just used significant indentation for. But it's the same kind of thing in the resulting syntax tree. All right, so enough about trees. How did you actually write the thing? How can we manipulate that syntax tree to output something? Right, so we're going to talk about how I did it, particularly in Black, which is one of the possibilities. It's not the one possible way, right? I'm just telling about the story of how I wrote the thing. If you're just interested in using it, you can install it right now and whatnot. But for me, let me try to convince you first before we get to the trees. Why did I want to write a new auto formatter in 2018? Isn't that crazy? We already had a few, right? We had AutoPep8, we had the app. IDEs like PyCharm implement their own auto formattings. Why would you create yet a new one? There should be only one, right? If you think about the Zen of Python. So my design goals were as follows. I didn't want to have a configurable one. I wanted to have one that just formats things the same way every time. So I wanted it to be opinionated. I wanted it to be consistent so that it is easy to explain why it did a thing, instead of having it just be a black box that you cannot really inspect. I wanted it to be deterministic. What I mean by this is that if you are running an auto formatter over the same file twice in succession, right after, one run after the other, you want the result to be always the same. And in AutoPep8 and YAP, that's not true. Sometimes the second run might actually yield a different result. And I want it to be fast, obviously, reasonably fast. But what I mean is, back at Facebook, some of the files that we're dealing with are megabytes big because they're generated by some automation and their configuration that we're dealing with. And auto formatting those files had to finish in sensible time, otherwise it's just useless. Right, so what are the actual parts of a code style that I wanted to be opinionated and consistent? There's 4 parts to it, really, if you think about this. Let's go through all of them now, so you can see, how the Black code style, which is a subset of Pep8, solves all of those 4 things. So horizontal white space is kind of easy because it's when to put spaces and when to avoid them. One example that I like to give is this: you should put spaces around equal signs, unless it's a default value of an argument, then don't. Unless that argument is typed, then do it. So there's rules that we have to literally implement in Black that just if else, do that. And some of them are surprising, and people to this day sometimes would report issues on this. But Pep8 really says this, that if you have a non-trivial side of a slice, you should put the slice colons with spaces around them. So that's what Pep8 says, and this is what we do. Vertical white space, kind of easy too, right? It's like what tokens always to break on, what tokens never to break on, how many empty lines to use. So the simple thing is this, like I always break after columns like that, right? So we're gonna always do this. And between functions, well, if you are module level, just put 2 new lines. If you are in a class, just put 1 new line. So that's easy. But the non-easy thing, and the one that people are very often opinionated against, and they're like, this is so weird, is the sad face. So the sad face is what is produced by having a function signature being long enough that now you have this dedented closing parenthesis and colon. Well, why do we do this? Well, like, I thought about this. I was actually writing code manually like this before I wrote Black, and the reason why is that this is the same kind of formatting as we would apply to dictionary lists and tuple literals. This is how you would, format your data structures anyway. So doing this is actually very useful. It has this nice property that it splits visibly the function signature from the function body. And you can get away with this without introducing additional indentation and just moving stuff around just so that it's clear where the function signature ends and when the function body begins. So this is why we have the sad face. It is weird for a while if you just are introduced to this style, but you'll forget about it soon enough, and it provides consistency across all those language constructs. All right, so that's it. Like one thing that you can see, like in red here, is that we have this trailing comma. Those trailing commas are only possible when you're using variadic arguments in Python 3.6 and newer. So Black is gonna detect whether you're using Python 3.6 features in your file, and then it's gonna put the trailing comma. If not, then it's gonna play it safe and not do it, because otherwise the grammar would just not accept it. It would just say syntax error. So line length, that's easy, right? Which one should we use, 80 or 120? Well, neither. We're using 90-ish. Like Raymond Hettinger had this wonderful talk called Beyond PEP 8, where he uses, the wealth of his experience to just say that, in his practice as a teacher and as a consultant in big companies, we are just missing a few characters to be happy, right? We usually have a module that has a class. Those classes have methods. Those methods gonna have some if statements. And finally, you lost enough levels of indentation that there's not much space for your logic anymore. And just adding a few characters beyond the 79 that PEP 8 says solves the problem entirely. And I was like, okay, I trust you, Raymond, but let's test it. At Facebook, I had access to tens of millions of Python code, so lines of Python code. So I ran Black with different kinds of configuration. Like, what if we do 79? What if we do 80? What if we do 88? What if we do 120? And I was looking for how long the files are going to be in terms of how many lines are they producing. And it turns out that after 88, the difference is really small. It's mostly those few missing characters that cause those ugly formattings to appear everywhere and those big folds to appear everywhere. So 90-ish it is. And then, like I said, I wanted everything to be consistent, so we have trailing commas, and we're standardizing on one kind of string quote. Because if you have this, is this an empty string or is it a double quote character? Well, you will never know if I don't tell you. No, we standardized on double quotes. Double quotes are nice because they anticipate apostrophes in your text. They're already what you were using for docstrings, and they're the same in C, and you interact with C a lot when you write Python. So to see how we actually implemented Black, we have to think about what does it actually do and what is it that it is formatting? Well, it's formatting lines, right? Those lines can be 120 lines long, 20 characters long, or 80 or whatnot. But what is a line really, right? So when I was thinking about this originally, I kind of liked what YAP is doing for the same purpose, which is that each line is this theoretical line that we would put, a single statement or expression or whatever else, this single fragment that we would use if there was no limit for the columns that we want to use, right? So sometimes it's going to be 3 characters, sometimes 8, and sometimes 279. So it's this theoretical line that we would use if there were no column limits. So we produce this one first from this visitor that just like feeds from your initial file. We read it. And then the super simplified algorithm goes like this. We create a concrete syntax tree from this input file. Within that tree, we generate those theoretical lines. And when a new line is generated and its length requires splitting, we do split. That magic is going to be explained a bit later. And for each split, we still look like, is that fitting now, that column limit? And if not, we just split it again. And then we track blank lines, because separately we need to know like how many blank lines to put in a given place. We also like track comments and stuff like this. But the rule is this, like a line once formatted and emitted externally is not touched again. So we just do one pass. That makes it predictably fast and linear, right? And not quadratic. So the thing that I always like to mention about Black is that it doesn't really look at your pre-existing formatting. Like with the obvious exception of empty lines, it will preserve if you had like two like somewhere, or if you had one, it's not going to remove this one between statements. It's just going to leave it. Same with comments. It really tries hard to like keep comments where you wanted them, which is not super easy. But the most I don't know, value added of Black is really just splitting the lines. So what kind of splitting does Black do? There are actually two kinds of splits that you can use, and we're going to just like go through them. So the first one is bracket split, meaning if you have a line and there's some pair of brackets in it, how should you break them? Well, either you can break after the first bracket, the opening bracket that you found, or you can break after the last bracket on the line. And it turns out that breaking on the last bracket, so the right-hand side split, just looks better for humans, because humans write code from left to right, and they go as far as the column limit will let them, and only then they will realize that, oh, I'm at 80 now, so I have to split. So they will split. And this is how most code in real life is written, which is why people really like to read code written that way. However, there are certain cases, like function signatures, where the left-hand side formatting is simply way faster and just produces better results. So we use this too, but in a very limited setting. Almost everything is the right-hand side splits. And then, once you already split on brackets, you have this massive body inside that still might be way too many characters on a line. So what we do is we are looking for delimiters now. Are there any delimiters? And what are those? Well, operators, commas, spaces between consecutive string literals, standalone comments, so that comments that are just appear on their own on a line. And like we discover them, they have priorities. So like certain ones just are more important than others. And if there's at least two of a kind, then we're going to split and check whether that now fits a line. So those split lines are still valid Python, even though they look weird, if you just look at this one line, but because they are within a bracket pair. So significant indentation in Python does not apply to them. So going back to this, and I don't really expect you to read this now, we visit the tree, right? We still put at most one statement per line. We split, we are attempting either the bracket splits or the delimiter splits. But we visit the tree, right? So how does the visitor work in Black code? Well, the visitor is essentially a generator. It will generate lines one by one. And then, so this is the actual abstract visitor implementation that I'm using. Then, for example, the debug visitor that I used to do this graphical representation that we looked at before, just fit in one slide. I don't expect you to read it now. I just wanted to show you that it's rather easy and usable in practice. Especially that on the user side, you just iterate over the call to the visit method. So this is actual code from Black, where you go for every line, we're going to do things, right? So maybe we should have some empty lines before and after, right? We're going to add some contents from those empty lines, and then we're going to just split. So for line and split line, let's just go and add things to destination contents. And later on, we're just going to emit them to a file. So that is the core of it. And now you know how Black works. So you can just look at the code, and if something is surprising you, it shouldn't anymore, because that is really how it works. The entire thing, including all the edge cases and handling of multiprocessing and whatever, is 3,500 lines. It is really, possible for us to understand how it does the thing it does. There are other possible algorithms, some of which might be like what YAPF is doing and whatnot, but I won't cover them. Just going to the fun problems, the most fun problem with a project like this is users. So users are lovely, right? Most of them thank you a lot. They report actual bugs. They are patient, considerate. It's amazing, right? Some users disagree with your choices because it's an opinionated formatter, and that is okay. It's fine for you to disagree with an opinion. That is fine because there's no hard truth to what I'm doing. I have some reasoning for things, but it's fine for you to disagree with me. But some people are offended by your choices. They demand change. And they submit unsolicited pull requests and make scenes when you decide against merging them. And that is sort of kind of, that brings you down. That is annoying. Some demand configuration, and I gave some of the reasonable, I guess, wants, but people always demand more, even though they love your product because it is not configurable. So, you cannot have it both. Some don't read the documentation. If it's too short, then you're like, you don't have it in the documentation. If it's too long, then they're like, too long, didn't read. So open source is really a labor of love. When I first released Black at Facebook, actually most people were happy about this. I was very happy, but not everybody was happy. So you can decide if you are one of those 324, or you're just one person here. But it seems like the project is popular. It is actually, almost reached 10,000 stars on GitHub. Please help me get there. Obviously, GitHub, sends a cake to people that get 10,000 stars, so I heard. It is downloaded pretty often, and who downloads it? Well, PyTest, Talks, Pyramid, Django channels, Hypothesis, Adders, Poetry, PyPA applications like Warehouse, pipenv, and Virtual, and many others. Soon maybe Django, Twisted, and Flask, from what I've heard just in the hallway track. So that's pretty cool. But not all is easy. Handling comments was very hard because comments are not part of the grammar. They're part of this white space that you just throw away. So making sure that they're still there where the human thought they put them is actually very hard because they're not sticky to the place a human thought. They just come after some token and before some other token. So this required rather tricky, heuristics. Optional parentheses, what do they mean? Well, in Python, for example, an if test doesn't have to have parentheses around it, but it might. And sometimes that will format things better. So should I put them or should I not put them? Well, this is tricky as well, right? So that was a thing. Sometimes you have a legitimate reason not to format a bunch of code. So there's format off and format on. That was also tricky to implement. And finally, determinism. We are safe to use. Black is safe to use because it will actually format your file twice internally and check whether the results are the same. If they're not, it's going to raise an error. That there's a bug, there's an internal bug that should not have happened. So determinism actually had some issues there. Accidental quadratic behavior was, annoying. So those kinds of projects tend to be very complicated in the most unexpected places. So what is the status of Black? Should you use it today? Should you wait? Well, the grand plan for the project is something like this. Oh, not this slide. Yeah, so stable, right? And we are literally here. At the sprints after the conference, I'm going to build a stable version and we're going to be done. So you can use it. Is it safe to use? Yes. It not only checks whether the formatting is deterministic, what it also is doing is it's going to check that the AST, so the abstract syntax tree, is the same before and after. So it didn't break any code. Python still sees exactly the same thing. So quickly, because I'm over time already, tips and tricks for adoption. Git hyperblame lets you ignore and bypass certain commits. So if you are adopting Black, create a massive commit that formats everything, and then use Git hyperblame to see blame as if nothing ever happened. Then, if you have pull requests that were open in the moment that you migrated to Black, there is a button that you can press, command line instructions, that will show you how you can pull the pull request locally, formatted with Black, and push it back. And then use pre-commit so that your code stays blackened even if you have many contributors. I don't take any questions now because I'm already over time, but I'm going to have a poster on Sunday morning, and I have stickers with it. So if you want to share some love or hate, please do it on Sunday morning. Thank you very much. My name is Łukasz Langa.
Thank you, Łukasz. Thank you, Łukasz. So no Q&A. Please give him another round of applause.